Now this is quite important. What happens after the Big Bang? So, in the beginning, yeah. So you have this first kind of blow up. Everything in existence suddenly came about. Let's put it that way. Okay? Almost suddenly, within a second. Then came about. After that, we have this afterglow of the Big Bang, which is the cosmic microwave background. Okay. Now, at this point, there are no atoms. It's just pure energy in the form of these oscillations of the quantum fields, as in the current understanding. Tapi the CME itself is not uniform because what you have are quantum fluctuations at very, very small scales, and they kind of get magnified as you blow it out. As it cools, so you have these you have these quarks and hadrons, not hadrons, quarks, and all these elementary particles sort of whizzing about. As space expands, everything starts to cool down. As things cool down, because you have these patches of irregularities, eventually what you have is you have an agglomeration of these particles, quarks and whatever, within these higher density patches. So higher density meaning higher energy patches. So you get this agglomeration of these particles. At some point, protons are formed, and neutrons are formed, right? And then hydrogen is created. Once you have an electron, so initially they are the neutrino. So if you remember in the end. And then from the first stars, then you gradually form galaxies. Because then the stars began to stick together and form galaxies. And then at some point, some of these stars, some of them are larger and some of them are smaller. The larger ones explode, creating supernovas, and so these are the things which create heavier elements. So if you remember when we did chapter 4, remember when we did this, going here is going to be fusion, going here is going to be fission. The question is this: if going here means that this is more stable like atasnya, so if it's more stable here, how do all of this get created? Because you started off with hydrogen, you can fuse and make helium, and then you can fuse and make carbon. Yeah, you can fuse and fuse and fuse, but at this point it should stop. So the question is, why do we have all of this? That's the first question. Second question is, why do all of this exist on Earth? That's the second question, right? So these two separate questions. Now, what happened then is these massive stars, they basically blow up, and because the energy is so big, even though it's less stable, they fuse to make other elements. And so, our star, which is the Sun, is not the first star which is in existence. It's a product of other stars which have died, and then the material has been kind of recycled to create something like that. That's why that's why we are what we are, so to speak, in that sense, right? In some sense, it is true that things like iron cannot be made in the star. It has to come from somewhere else. Okay? sama ada, it could be the case that you have, macam a meteor which strikes ataupun some other stuff which strikes Earth and then it could not have come. It must have come from a larger star because this is the process that we know of. Now this entire story, Dr. Haskiza is one of the people yang cuba buat the process this. How galaxies kind of form. So that's a area of research. Tapi because of the James Webb Telescope, some of the theories too kena adjust. I don't know what it is, but apparently some of the galaxies that they were saying that they were seeing should not have formed when it was formed. So it has to be formed. I mean, this is still the dominant kind of paradigm in which we are operating in. Now, obviously, we are here. One question that might come up. Biasanya kalau soal exam, I just explain. Biasanya it's like inflationary theory or something like that. So if this comes up, it's not very difficult. Just need to kind of know what it is. I think this one has come up before. Again, when this comes up, it is always the case that what are the evidence of dark matter and stuff like this. So this one is also quite important. Okay, so I think so finally this is clear. Yeah, so I'll explain this again.